This is a video on kinematics of particles. This is the 16th video and we are dealing with collision of particles. Now, see, collision of particles can also be considered as part of kinetics of particles. Sometimes they are also treated as independent topic. Anyway, this video 6, we are going to solve some more problems on pendulum. That is, pendulum is going to hit the wall, then the bullet is going to hit the pendulum. Let's see the problems. Okay, problem says like this: a simple pendulum, when released from rest in the horizontal position, falls under gravity and strikes a vertical wall as shown in figure. So see, pendulum was held like this, then it is that bob is like you release it from here. It will fall down and hit the wall, and then it will rebound. So what they are saying is, if the coefficient of restitution between wall and the ball is 0.5, we want to find the angle theta defining the total rebound of the ball. So what they are asking is, up to what angle it will rebound. That's what is the question. They want to know the theta. So our approach is like this. Well, this was held in horizontal position and then it has fallen. So before it hits the wall, it achieves velocity of √2gl because the body has fallen through height L. Now, because it hits an body of infinite mass, that is wall, it rebounds with velocity of e√2gl. This aspect of collision with infinite body we have done in previous videos. So here we'll just accept that it rebounds with e into √2gl. Now when it rebounds, it goes up like this, say up to some height h, and that height h will be related to this v by again √2gh. So if I equate e√2gl with √2gh, I can work out h, and which comes to 0.25 times L. And then using this geometry, see, this total is L, I remove 0.25 L, so this base of this triangle is 0.75 L, and then we can find out theta, because we know this hypotenuse and we know the base, and theta will come out to 41.42 degree, and that's what was asked. Look at the second problem. This says a ballistic pendulum consisting of a block of mass 30 kg suspended from two wires, each of length 1.8 meter, is used to measure the muzzle velocity of the gun. If the pendulum swings through a horizontal distance s is equal to 25 centimeter, when a 40-gram bullet is fired into it, determine the muzzle velocity u1 of the gun. Now see, this is a typical, actually this pendulum is used to measure the velocity of the, it's a standard equipment, and just for the simplicity, these two wires were combined into one, and problem goes like this, that it is this hanging here, bullet hits, it goes up, and that distance they are given as 0.25, and from this, because this is 0.25 and 1.8, we know the geometry of the triangle, and from that we have worked out this height to which this has gone up, and that is 0.017445. Now we write our governing equation, that is conservation of momentum and velocity of separation upon velocity of approach is minus e, and start putting in the values. See, m1, the 1 stands for bullet, so m1 is the mass of the bullet, 40 gram, that is 0.04 kg, multiplied by u1, the velocity of the bullet which I want to find out, m2, the mass of the ballistic pendulum, and u2 is 0, so that term doesn't exist here, and then it is equal to m1 v1 plus m2 v2. Now you see, we will assume that the bullet gets embedded into this bag, and together they move with velocity v. So if we say that v1 and v2 are like v1 is equal to v2, or rather we say, and now this is called plastic impact. In plastic impact, E is 0. So if I put it E as 0, then we'll get V2 is equal to V1 and we'll call it V and we'll put it here. Now this V is related to this height through root 2GH. So V root 2G and this H gives me V as 0.585. It should be meter per second. The unit is slight error, meter per second. Fine. And now this value of 0.585 meter per second, when I put here, I will get my velocity U1, the muzzle velocity of the bullet, as 439.4 meter per second. Here there is see, velocity cannot be in meters, it's meter per second. There is a error here, but doesn't matter. When you put this number 0.585 here, you get U1 as 439.4 meter per second. So this is an equipment in fact used to measure the muzzle velocity of a bullet. You fire it into sandbag, see how much it lifts, and then it is calibrated and you get the velocity. Thank you.